We're going to look at compound interest and depreciation today. So there are three steps. The very first thing is we got to understand what the format of it. The second thing is we need to know how to calculate the year's amount and all that. The third thing is we need to be able to adjust. Just because they throw something at you, you need to be able to adjust and know what to do. So the keywords today are interest, percent, compound, and depreciation. So the very first thing is the formulas. Well, I really consider this to be like one formula, but the thing is that you got a plus when it's compound interest, when you're building on top of something, a negative or subtract when it's depreciation, when you're like losing value. So the idea goes like this. You have your old amount, you times it by 1 plus the percentage. And the key thing here is you always start at 100%. Doesn't matter if it's a compound or depreciation, still the same thing. And then your percentage has to be in decimal form. Then the whole thing is going to be to the power of years. You can do it separately, it's not a problem, but usually it's easier if it's to the power of years. So how you might see it on a test might be something like this. You get your words that are A, like let's say final amount, your P, which is your original amount, they call it the principal amount, I being the interest rate, and N being the number of years. It's just so that you get familiar with the words of principal and final amount, that's all. So here's a question for you to try. Pause for a bit. Okay, so here are the answers. How it works is you start with 12,000, you times it by 1 plus 0.03. As I was saying, this has to be in decimal form. That 100% and 1, they're really the same thing. That 3% is just another way of saying 0.03. So you combine it, it turns into 1.03 to the power of 5 because it's 5 years, and you get yourself an answer, 13,911.29, and that's your final amount. The second thing to watch out for in this question is this. If they try to throw like a, let's say 1 point something percent or whatever it is, it doesn't matter. Just be careful when you write this out. So in this case, if it's 3% to be 0.03, make sure that you write it out as 0.015 as your percentage, you add it onto it, and job done. You get yourself 12,927.41. Here's another one for you to try. This is depreciation. Give it a go. Okay, so how it works is we're looking at two different amounts, 10,000 and 100,000. So for this one, you're losing 20%. As soon as you drive off, you lose 20%. And if this trend continues, how much would the car be worth after 2 years? So this time, instead of adding, you're actually subtracting. So for here, you take your 10,000, you times by 0.80, because you subtract, to the power of 2, you get yourself 6,400. Whereas on this side, you start with 100,000, you times it by 1 minus 0.205, and that's because of this percentage here, which is just another way of saying 0.795. You do your calculation, this is how much you get left. So obviously, the higher amount that you start with, you're going to lose more. And for this question right here, it's actually really popular in exam questions where they give you two banks and then they want you to decide which option is better. So pause and give it a go. Okay, so how it works is I would do it this way. I'll set up as bank A over here as a equation, and then bank B over here. So bank A, because you want to invest 10,000 for 5 years, you're doing this. 10,000, and because each of the first year is 1.5%, 1, 2, 3, you're doing it that way. And then afterwards, it's 1.2 for every other year, 1 and 2. And if you just type it all on your calculator, you get this amount. As I was saying before, you can do this separately. You don't have to do it in the number of to the power of number of years. It doesn't really matter, but it's entirely up to you. So in bank B, same idea. Because it's 2% for the first 3 years, 1, 2, 3, and then 1% for every other, 1, 2, you do your calculation, job done. Comparing the two, bank B is better. Okay, this is our last one. It's slightly harder, and you need to think backwards. So I'll let you guys have a go at it, and I'll tell you the answer. Okay, so the setup is this. The idea is that 2 years has gone by, between 2015 to 2017. Both of them are being the 1st of January. So the idea is you set it up. Now I'm using A, B, and C just because we don't know what the amount is, doesn't matter. So A times 1.05 equals B, which means from 2015 to 2016. Because Martin withdrew £1,000, that B is subtracted by 1,000. That amount times by 1.05 gives you C. Now that C is our final amount, which is here. So let's go backwards. If we're timesing it, then our inverse is going to be divide. And if our inverse here is subtract, then it'd be inverse of to be positive, to be plus. So let's do it backwards. 22,000 divided by 1.05, we get that. We then need to add the £1,000 back in to get that. Finally, to take care of this one, we divide by 1.05, and we get this as our final amount, which is our original amount that we invested. So, these are the equations, and as a final summary, my thing is, just know your formulas. It's the same formula. The only thing is either it's going to be a plus or a minus. Always start 100%, and make sure that this is in decimal form, like 1 and 100%, they're exactly the same thing. If it's a multiple years with different interest rate, then write it out separately as a calculation. It just might help, but that's entirely up to you. And sometimes you might need to go backwards, so you might need to use divide. I hope you enjoyed this video. Thank you.